Hello and welcome to the Management Channel and welcome to the Management Operations section. This is going to be a rather long session. We're going to talk about product and service design. And our objectives here are to define a product life cycle, look at a product development system, learn how to make a house of quality, learn how to create a decision tree, and learn about customer interaction. So first of all, the objective of business, obviously, is to provide goods and services to customers. Customers buy satisfaction, not just goods and services. Therefore, great products and services are the key to survival in a business. Limited life cycles require redesign or developing new products, as new products develop renewed revenues. So, what is the objective of a product decision? It's to develop and implement a product strategy that meets the demands of the marketplace with a competitive advantage. The higher the percentage of sales from the last 5 years, the more the firm is likely to become a leader in the market. What does product and service design do? Well, it translates customer wants and needs into product and service requirements. It refines existing products and services, or develop new products and services, formulate some quality goals, formulate some cost targets, obviously, construct and test different prototypes, document all the specifications, and translate the product and service specifications into process specifications. And we're going to cover that in process strategy. Key questions you need to ask yourself first. What are you providing to your customer? How will you meet that criteria? First of all, marketing. Is there demand for it? How large of a market is there? How much can be created? What's the demand profile? Operations then becomes feasibility, manufacturing. Do we have the capability to produce an item at an acceptable profit? Serviceability. Do we have the capability to provide a service at an acceptable cost or profit? Quality. What level of quality is appropriate? What are the customer's expectations? And what kind of quality does our competition have? Does it make sense from an economic standpoint? Do we have any liability issues, ethical concerns, sustainability issues, costs and profits? Is there going to be a return on our investment? And IT says, what can my department do to help? And they, believe me, are the backbone of every business. The product life cycle may be the length of its life from a few hours to decades. The iPhone example. Every year they seem to have a new and better model with new features. The R&D department must create new products, and the operations function must be able to introduce those new products successfully. Why is that important? Well, obviously, to maintain a competitive advantage. There are other, for instance, an iPhone, there are other phone companies out there. Samsung is another one. AT&T is another one. So you want to have more features and more advantages with your product than the competition. The steps. Well, what happens during introduction? It's costly. There's research. You develop suppliers. You might have some redesigns, some failures, some successes. During the growth stage, the product design stabilizes and begins to take now an increased sales trend. So with effective forecasting of capacity, it is now necessary to forecast what you think you can do. By adding or enhancing capacity, you might even grow better. What happens during the maturity of the cycle? Well, some competitors also enter the scene. Product is established and the costs start becoming lower because there's competition. High volume, innovative production may be needed. You might need improved cost control, reduction in options, paring down of a product line, or doing a value analysis, which we'll talk about soon. The decline of the product. Well, everything comes and goes. The novelty wears off. The market's saturated. Consumers could buy the product somewhere else cheaper or with more features, or a new design is required, or what? Who knows? So when you look at it, the product life cycle is pretty much like this. In the introduction, you have negative cash flow. And as it starts trending up the market, you start getting a cash flow. And at the peak, you have sales revenue, net profits. And then as it declines, you start to lose money if you continue with the present cost. So we're going to do a product by value analysis. List products in descending order of their individual dollar contribution to the firm. List the total dollar amount contribution from that product annually. And it helps management evaluate alternative strategies. Is this product now dying? Should we abandon it or redesign it? What are some criteria for new opportunities? Well, first of all, you have to understand the customer. What do they want? What are they looking for? Is there an economic change? Is the economy going better or going downhill? What are the sociological and demographic changes? Are there any technological changes? What about political and legal changes or new requirements? And market practice, professional standards, a lack of suppliers, fewer distributors. So the product development stages go from concept to feasibility of can we do it? What are the customer requirements? What kind of specifications do they need to have? Then we review the design, we test market it, we introduce it into the public, and we evaluate and progress. Quality function deployment is probably a very important topic, and it's a process for determining customer requirements or wants and translating them into the attributes of the hows that each functional area can understand and act upon. An approach that integrates the voice of the customer into both the product and the service development. And the purpose is to ensure that customer requirements are factored into every aspect of the process. Listening to and understanding the customer is the central feature of quality function deployment. Can't satisfy the customer if you don't know for sure what they want. So you got to identify the customer wants. Identify how that good or service will satisfy that customer want. Relate customer wants to product hows. How can we do it? Identify the relationships between the firm's ability and the product needs. Develop some importance ratings. Evaluate what other products are out in the market already. What is our competing products? And compare the performance to desired technical attributes. So in a quality function deployment, you take the customer ratings, what the customer wants, and how to satisfy the customer wants, and put it into a relationship matrix with a weighted rating. So let's say your team has been charged with designing a new camera for Great Cameras Incorporated. The first action is to construct a house of quality. You do that by doing what I said up there in the first spot, what the customer wants and how to satisfy it. So we have to introduce a matrix. What the customer wants is a lightweight camera. Want it to be easy to use, reliable, easy to hold it steady, and possible color correction. And then you rate it in a scale of 1 to 5 of the importance. 5 is the highest. So the first thing is they want it to be reliable, easy to use, lightweight, easy to hold steady, and not so worried about color correction. And then we have to put in the material parts, the low electricity requirements, aluminum components. It should have an autofocus, auto exposure, should have a paint palette for color, and an ergonomic design. That's what the customer wants, and this is how we satisfy the customer's wants. Next, we take and make a matrix, lightweight, rating score. So high relationship, medium relationship, and a low relationship to what the customer wants and how we satisfy it. So you put that in the top up there, and you can see there's the relationships between the things that we can do and the weighted factor in the matrix so that we have an importance rating. So the most important thing is number 32. Color correction and easy to use and reliable. How well do competing products meet customer wants? So we look at the competition. And we see company A and company B. And then we rate good, fair, or poor. How we relate to theirs. Next, we hit the target values, the attributes. 0.5 amp, company A has 0.7 amp, company B has 0.6 amp, we have 0.5. And then you can see the other categories in there as related to the competition. I'll leave that for a moment for you to explore. So the completed house of quality looks like this. Remember the first design that I showed you, and this is how it looks when it's all finished. I'll leave this for you for your review for a moment. Please feel free to pause if you'd like. So the house of quality sequence is deploying resources through organizations in response to customer requirements. So you want your design characteristics, your specific components, the production process, and the quality plan. Product development usually is done with a product development team or an R&D team. And they're a team charged with moving from market requirements for a product to achieving the product success. Concurrent engineering is bringing engineering, design, and manufacturing personnel together in the design phase early on. Usually involves manufacturing, marketing, and purchasing personnel in a cross-functional team. And there are views of the suppliers and customers also present. The purpose is to achieve product designs that reflect the customer wants and relationship to the ability of the manufacturing company to produce it. Manufacturing and value engineering, the benefits are reduced complexity of products, reduction of environmental impact, very important, additional standardization of products where possible, improve functional aspects of the product, improve job design and job safety, improve maintainability or serviceability of the product, and create a more robust design. A value analysis is an examination of the function of parts and materials in an effort to try to reduce the costs or improve the performance of a product while still meeting customer wants. Common questions used in a value analysis: is the item necessary? Does it have value? Could that part be eliminated? Are there alternative sources for the item? Could another material, part, or service be used instead? Can two or more parts be combined? Can specifications be less stringent to save time or money? And can packaging be improved or made less costly? Packaging is a big cost factor. So the value analysis is focused on designing improvement during production. Seeks improvement to a better product or product to be produced more economically with less environmental impact. So let's say the first design cost you $350 and note all the parts included. So now you cut down a couple of the parts, and now the cost to produce it is only $2. But with another exploration and review, you're able to get it down to 80 cents, which means you can sell it at a cheaper price now. So the cost reduction of a bracket via value engineering starts at $350, goes to $2, and finally ends up at 80 cents by eliminating unnecessary parts. Methods of product development is like, for instance, a robust design or a modular design, a CAD or computer-aided design, a computer-aided manufacturing or CAM, virtual reality technology, value analysis, and sustainability with a life cycle assessment. So first of all, what do we mean by robust design? It's one that results in products or services that can function over a broad range of conditions. The more robust it is, the less likely it will fail due to a change in the environment in which it's supposed to be used or performed, and typically results in lower cost with higher quality. Modular design are products designed in easily segmented components. It adds flexibility to both production and marketing, and improves the ability to satisfy customer requirements. Computer-aided design is using computers to design products and prepared engineering documentation like blueprints. There are shorter development cycles, improved accuracy, and lower costs. The information and designs can be deployed worldwide to any supplier. And the design for manufacturing assembly solve manufacturing problems during the design stage. 3D object modeling helps you to make small prototype development. CAM, on the other hand, is utilizing specialized computers and programs to control the manufacturing equipment, usually driven by CAD. The benefits of CAD-CAM are product quality, shorter design time, production cost reductions, database availability, new range of capabilities, and I'm going to add quicker to production. Virtual reality technology, computer technology used to develop an interactive 3D model of a product from the basic CAD data. It allows people to see the finished design before a physical product is actually built. It's very effective in large-scale design sense, such as a plant layout or a facility layout. Product development continuum, product life cycles become shorter, and the rate of technological change is constantly increasing. Developing new products faster can result in a competitive advantage over your competition. And time-based competition is competition based on time, rapidly developing products and moving them to market before the competition does. Processing technology by acquiring a firm speeds the development. Through joint ventures, both organizations learn and the risks are shared between the two companies. And with alliances, cooperative agreements between independent organizations, very useful when technology is just developing, and it helps reduce risks. So we want to define the project. First, define it in terms of functions. You need to have rigorous specifications developed during the design phase. Manufacturing products will have an engineering drawing and a bill of material that lists the components of the product. For instance, here is a bill of materials for Monterey Jack cheese. I'll leave this with you for a moment for your review. Pause if you need to look at it longer. Product documentations. Engineering drawing shows dimensions, tolerances, and materials, and shows the codes for group technology. A bill of material lists the components, quantities, and where they're used, and shows the product structure. Bill of materials. Here we have one from Hard Rock Cafe's Hickory Barbecue Bacon Cheeseburger. This is everything that goes on it and how many of each. You'll notice like 2 slices of cheese, 2 strips of bacon, 5 ounces of fries, etc. So documents needed for production. You need an assembly drawing, an assembly chart, a route sheet, a work order, engineering change notices if applicable. Assembly drawing pretty much shows an exploded view of the product. It details relative location to show how to assemble. This goes here, that goes there, etc. Assembly chart tells you the point of production where components flow into subassemblies and finally into the final project. And you can see 3 items here become this bracket, 3 items there become that bracket, and how they all come down to make the final assembly. A routing sheet lists the operations and times required to produce a product or component. It tells you the operation, setup time, and how long it takes to make per unit. A work order is a given quantity of a particular item, usually to a schedule. This part number, 125, start date, need to have it by 5/4. Which department and where it's delivered to. Engineering change notices happen. They are a correction or modification to a product's present definition or documentation, and usually contains engineering drawings which require a new bill of material. The product lifecycle management is integrated software that brings together most, if not all, elements of a product design and manufacture. So, product design, CAD, CAM, product routing, materials, assembly, environmental information. The process chain network analysis focuses on the way processes can be designed to optimize interaction between the business and their customers. And again, I will leave this with you for a moment for you to review. Please pause if you want. Adding service efficiency. Service productivity is low because of customer involvement in the design or the delivery of the service, and or both. Limit the options. Improves efficiency and ability to meet customer expectations. Delay any customization. Modularization eases customization of a service. And automation helps reduce costs and increases customer service. Next up, in our next topic, we're going to look at process layout strategy. Thank you for watching. Have a great day.